My name is Jess Tilli, and I am thrilled to share with you how we can use learning progressions to accelerate early mathematics. I am currently the Director of Math for the School District of Philadelphia and have served as a teacher, school-based teacher leader, curriculum specialist, and most recently a director over the past 15 years in Philadelphia. I have been deeply invested in figuring out how to support students and accelerate their mathematical learning so they can reach their limitless potential. Thank you for joining me as we consider how we can utilize learning progressions to do just that. By the end of this session, you will learn more about what learning progressions are and what the research says about them. We will explore the false sense of insecurity and security educators gain from the types of data that are traditionally used in schools and in school systems. And finally, we will consider how educators can use learning progressions to inform their instruction and accelerate learning. Before we jump into learning about learning progressions and how we can utilize them to accelerate math, I want to start by grounding us in why this work is so important. As you can see on the screen, strong number sense is one of the greatest predictors of a child's future success, not only in school but beyond. Various studies have looked at how early number sense and flexibility with number affected later achievement in math. In each of these cases, they interviewed or evaluated students' number understanding in early grades, and then tracked the students' performance in later grades related to mathematics. The findings indicate that students who struggle with number sense in early grades have issues that persist into later years, and they progressed at a slower rate in mathematics. All of these studies indicate that early flexibility and good reasoning with number is an indicator of future success in mathematics. So now let's talk about what learning progressions are. Learning progressions provide a map for how students acquire mathematical knowledge and skills. They are research-based descriptions of successively more sophisticated ways of thinking and doing as children develop understanding and fluency of a topic. They provide insight into how students grow from the least sophisticated, most concrete understandings to the most abstract. In school, most of us experience some manipulatives at first, getting to count things, but very quickly we were moved to the abstract algorithms. We miss that middle part, a part of that progression that transitions us from early counting to additive reasoning. Developmental progressions, like the one you see on the screen from the ongoing assessment project, characterize common pathways that students take when learning mathematical concepts. But we know students often learn at their own pace and acquire skills at different times. When teachers are aware of the skills and concepts students need to move forward, they are better positioned to use that information to more effectively respond to students' needs, while at the same time building on their current level of understanding to move towards the mathematics. Julie Sarama and Doug Clement state that learning progressions can help teachers see themselves not as moving through a curriculum, but as helping students move through levels of understanding and can positively affect student motivation and achievement. If you look at the framework on the screen, it was designed by OGAP to support teachers in making more informed instructional decisions in an easily digestible, user-friendly format. This particular framework focuses on additive reasoning, but there are frameworks for other critical math areas which include base 10, subtraction, multiplicative, fractional, and proportional reasoning. At the bottom of the framework are different possible errors or misconceptions students may have, and above that is the lowest level strategies for addition, which include early counting strategies and then counting on. As we move up the progression, we can find transitional strategies that students need to understand in order to transition to additive strategies like partial sums and algorithms. That's not to say that students can't use an algorithm effectively, but their understanding of that algorithm may not exist if they haven't gone through the transitional phase and developed that conceptual understanding. All of this provides instructional guidance for our teachers. The progression is non-evaluative. Students can move up and down the progression based on the content they're learning and the complexity of the numbers they encounter. Movement along this progression is not linear. Just because a child is transitional in one skill does not mean they're transitional when that skill is different. They can move up and down the progression. Now let's consider the data we use versus the data we don't. I want you to consider the following scenario. Both student A and student B show up in green on the online adaptive software and progress monitoring tool. The teacher is happy to see that both students are doing well, and the teacher is under the impression that they know what they're doing. The teacher is, however, unaware that student A is using a counting strategy to add and subtract, while student B is using a sophisticated strategy to add and subtract that is in upper transitional. While both students appear to be okay, the teacher cannot glean their strategies and understanding from the tool. The limitation of these assessments is that you gain no insight into what students know and understand. The strategy a student uses is an indication of their efficiency, and less efficient strategies use more working memory, making it more difficult for students as they progress in mathematics. What these two students understand is vastly different, and that has critical instructional implications. We get a lot of false senses of security and insecurity from these assessments because we think students either have it or they don't, because all we're paying attention to are correct answers and incorrect answers. Consider the problem on the screen. Miss Brown's class collected $72 for the school fundraiser, and Mr. Smith's class collected $29 for the fundraiser. How much less money did Mr. Smith's class collect than Miss Brown's? Show or explain how you know. Student A, B, and C all got the correct answer, but how they thought about the problem was vastly different. Student A is using a counting strategy to solve this problem. In a minute, we'll revisit the progression, but as we discussed earlier, counting is the lowest level strategy a student can use. This student needed to see all the ones. They had to spend time with their working memory, keeping track of every single one of these circles and making sure that they drew 72 and then crossed out 29. That is a tax on a working memory. Student B is using a much more sophisticated strategy where they are flexibly using a number line to solve this problem. This student does not need to see all the ones and can even make a jump from 29 to 69, and then add one more to get to a decade number, and two more gets them to 72. This is a very sophisticated way of solving this problem. This student understands that the distance between 29 and 72 is where the answer lies. Student C is using a base 10 drawing to derive the answer. While this strategy is more sophisticated than student A, ultimately it is not a strategy we want to leave students with, because the way you use base 10 drawings is by counting to some extent. On a computer-based assessment, these students will all look like they got it right, but instructionally, they are in very different places and need very different instruction. That's why we must use data at the classroom level on an ongoing basis that goes beyond the surface level correctness of the work. We spend hours in schools marveling at the data we receive from computer-based assessments, admiring the problems, the gaps, and all the red and yellow. But how is that information actionable for teachers? If we do not take the time to analyze student work and identify what strategies students are using and what they understand, How can we possibly move them up this progression appropriately and make sure that they get to mastery? Students A, B, and C are at very different places on the progression. Student A is at the lowest level of the progression, while student B is in the early transitional phase, and student C is even higher on the progression in transitional. If the teacher leaves student A in counting, student A is going to struggle as numbers increase. Student A may survive while the numbers are smaller, but next year, student A is in big trouble as they progress. The only way to know where student A is and what student A needs is to know how they are thinking about the math, not just whether or not they got the answer correct or incorrect. With student A, my next instructional move may be to try to get them to a place where they can rely on a counting on strategy, because that would be the next level up on the progression. Knowing where students fall on the progression has major instructional implications. So let's continue to think about how learning progressions can be used to accelerate learning. In the book, Learning Trajectories for Teachers, Designing Effective Professional Development for Math Instruction, Chapter 2 describes some of the best use cases for learning progressions. Teachers can use learning progressions to select tasks, identify short-term goals that relate to long-term mathematical goals identified in the progression, and adjust tasks based on where students are on the progression. Teachers can anticipate strategies students may use and possible misconceptions. They can anticipate the varying levels of sophistication amongst their students' approaches. They can also use learning progressions in their instruction, focusing on students' process and recognizing the different levels of sophistication in the moment. That's some of the hardest work that we as teachers do, that in-the-moment decision-making, and learning progressions can inform that decision-making. Teachers can ask better questions to support students in making explicit connections between different levels on the progression. Teachers can also use learning progressions to assess student knowledge using meaningful evidence of student thinking. They can use the learning progression to consider the range of student understanding in their classroom and draw upon the learning progression to structure class discussions that provide opportunities for students to consider more sophisticated strategies. This is the cycle that the ongoing assessment project shares with educators. The first step is to gather evidence from students. This could look like giving them a task similar to the school fundraiser task, and then collecting their work. Once their thinking is gathered, it is time to analyze it. Teachers can use the progressions to sort their students' work based solely on the strategies they used. They can think about the good news, what's concerning, and most importantly, what they're going to do about it instructionally. We've done work in Philadelphia with the ongoing assessment project, and when teachers have utilized this cycle in their professional learning community meetings and with their grade teams, not only were they better able to respond to the needs of their students, but the way they talked about students shifted. We operate in a very deficit-based industry, focusing on identifying and addressing students' weaknesses and shortcomings rather than nurturing their strengths and potential. This approach is rooted in the belief that students are lacking in certain skills, abilities, or knowledge, and therefore need to be fixed or filled in with the missing pieces. It is deeply entrenched in our system and often neglects the diverse talents, interests, and abilities that students possess. Engaging in this cycle and thinking about learning progressions along the way provides more equity and access for our students and shifts education from deficit-based to asset-based. We cannot fill gaps and accelerate student learning unless we know what students understand and can do. We cannot build off of holes, but we can build off of the foundation that students have. So we must embrace a more asset-based way of thinking about student understanding. When teachers understand and use learning progressions, they can make better instructional decisions, select more impactful activities to do with students, support more engagement and discourse, and use evidence in student work to better support students. Ultimately, there is a positive impact on student motivation and achievement. When learning trajectories are utilized by teachers, they can be powerful tools to support them in supporting their students who are struggling. They are a tool that teachers desperately need to diagnose student understanding and truly accelerate learning. As you can see, the quote on the screen says, "Learning trajectories translated into usable tools can help teachers rethink instruction, assessment, and interventions for students who fall behind. They will make it possible to improve teacher diagnosis of student understanding and enable teachers to practice adaptive instruction." Beth Holbert, who leads the ongoing assessment project, always says that a program is only as good as the teacher using it. If we don't give teachers the support they need to understand how students learn and acquire mathematical knowledge, then we will not be empowering them to use learning progressions to truly accelerate the learning of their students. So some key takeaways. Learning progressions can be used by educators to plan, instruct, and assess. When teachers are armed with the knowledge and understanding that learning progressions carry, when they practice using learning progressions to sort and analyze their students' work, when they use them to make instructional decisions, they are better positioned to meet the needs of all of their students. The most effective math instruction is the instruction that is informed by students' day-to-day developing understandings, common errors, misconceptions, and preconceptions. Again, a math program is only as good as the teacher using it. And when a teacher continues to move through a program without considering what students know and understand in front of them, then they will not be able to use effective math instruction. Teachers make better instructional decisions when they deeply understand the learning progressions and how to use them to respond to student thinking. Math programs rely on teacher content knowledge. Learning progressions provide opportunities for teachers to better understand the math they are teaching, and they prepare teachers to look at student work and respond accordingly. I want to thank you for listening and learning about learning progressions. I have found them in my career to be an unbelievably powerful tool that changes the narrative about students and ultimately leads to more math achievement. Thank you. If you have any questions, never hesitate to email. Hi, everyone. Thank you so much for watching and for joining me today to think about how we can use learning progressions to accelerate early mathematics. If you have any questions that you'd like to ask in the chat, please make sure to drop any questions there, and I have some time to answer. While I'm waiting for some of your questions to come through, I was thinking as I was rewatching this, some of you might be wondering, how do I get started? How do I change the way we think about assessment, whether you're a teacher, a school leader, a district leader, or at a different level? And I think that what I would say is the biggest shift is around using student work analysis. And so what that really looks like, it's most helpful to have the learning progression next to you. But if you are not ready and you haven't been trained on using a learning progression, the first step is just to collect student thinking, student work, and sort that work based on strategy. Now, you then have conversations and you really look at that work. Now, when I say sort work, I'm not talking about an entire assessment. I'm talking about one task, those open-ended questions that really provoke children to show their thinking. Or maybe while students are counting collections, you're observing and you're watching the way they do it, but you're really thinking about what is the strategy that my students are using and how are they thinking about the math. That right there starts to change the conversation. So I really have sat in quite a few meetings where I watch teachers and school leaders look at an assessment, like I said, a computer-based assessment, and they make decisions like grouping kids, grouping students based on those assessments. And I hope that after watching my presentation, that you'll realize that that's not a pedagogically sound way to group children, especially given the examples I provided, where one student might have gotten the answer correctly, but is relying on a counting strategy, and another student who got the answer correct is using partial sums as an example. Those two students have no business being grouped together because they're on vastly different places. Now, unless I'm trying to do heterogeneous grouping, which could apply, but if my goal is to work specifically with a student or a group of students and try to push them to the next place on a progression, I really want to make sure that I'm working with students based on sound data. So I really would say to you all that just starting with a simple student work analysis where you ask 3 questions. What's the good news? We always ask what's the bad news. Let's start with what's the good news? Sometimes the good news you have to reach for. I've been in PLCs or professional learning community meetings where the good news is no kid wrote IDK. Okay, that's the good news. But we have to start with what the good news is if we're going to shift from a deficit-based field to a more asset-based field. But what do some students show they know? Or again, maybe no one wrote that they don't know how to do it. The second question is, what are we worried about? Is there evidence in some of our students' work that there's a really strong misconception? Then we're going to discuss it then and there. But the most important thing we need to do is think about what are the instructional implications? What am I going to do about the work I just examined? And one thing I realize I didn't mention in my presentation is that that cycle should never be more than 48 hours. So I've gone to PLCs where they were looking at, they were doing student work analysis with work that had been a week old. There's no point in looking at work that was a week old because you can't respond appropriately now that that time has lapsed. So the way to do it is you look at the work and you respond to it within 24 to 48 hours. If you can't do that, the work's not worth looking at. It's not, because part of looking at the work isn't just to reflect and think about how we did. It's really about what did the students do and how am I going to respond to it? I see a question in the chat. As someone who helps create and provide professional learning for school divisions, can I access resources that can help me apply this concept to PL that I'm creating and providing? Absolutely, Melissa. Thank you for that question. So the first thing I'll tell you, Melissa, is, and I can't seem to type anything in this. I can't like share a link with you, which I had ready to go. But if you go to OGAP's website, they actually made their frameworks publicly available. So you could start with grabbing the framework that applies to whichever group of teachers. So if you're working with pre-K 2 teachers, you could pull up the additive framework. Maybe this it's multiplicative. They have all of the different frameworks that you could use. And they even have a protocol for student work analysis, which literally are those 3 questions that I just shared with you. What's the good news? What are we concerned about? And what are we going to do about it instructionally? They also have, there are a few books that I swear by that relate to this as well. The first book is called A Focus on Addition and Subtraction, which was written by Caroline Ebby, Beth Holbert, who was also head of Ongoing Assessment Project, and Rachel Broadhead, I believe. And they write, their book is exactly what I'm talking about, and it walks you through how to look at student work, how to use research to make those decisions. And if you shoot me an email, and I did share my email at the end, or maybe I can share with the producers of the summit some of these resources so I can get them to you. But my email is jlauer@philasd.org. They kind of put that down pretty quickly, so I'm not sure. I also am on Twitter if you want to connect there at Jessica Tilli 1. So if that's an easier way for you to connect with me, I'm happy to share anything with you. But I do think that using this with teachers is just unbelievably powerful. And I would absolutely be creating opportunities for the teachers you support to learn more about how to do this work, how to look at learning progressions. And I will say, even with limited training on the progressions, you can put the progression, you can pull it out and it's printable, and you can sort student work and you can just try to map it. Even with, I mean, best case scenario is you get trained on the learning progressions, but even with limited training, I've seen teachers just pick it up and just try to use it. And already you're using a one pager that's filled with the research on how children acquire mathematical understanding, and you can use it that way. So it's pretty simple to sort of just try to use. And again, that book, and there's a series. So there's that book, a focus on addition, and then there's a focus on, I think, multiplication and a focus on fractions. And it's all aligned with what we're talking about today. So I strongly recommend that book. And if I was able to share a chat with you, I would have dropped the link in the chat. But if you just look it up, a focus on addition and subtraction, it will pop up for you. If you have any other questions, please feel free to drop in the chat. I will just say that while I'm waiting for more questions, really the thing that from my level as a district leader, when we really want to make significant change, we really have to identify the champions in each school, or in whether if you're in a school, in each grade band, that are really going to sort of buy into this work and really do it and carry it forward. So the way that we really we worked around that idea and that concept of building capacity was not only when we trained an entire network of schools, we were looking for who are the people in these trainings that are really into it. Because you can, if you're facilitating professional learning, it's not hard to identify those people who are sort of drinking the Kool-Aid and getting excited about the thing you're sharing. And so we then, after identifying those people and their interest in being what we called facilitators, we then trained them up. And we trained them to even go deeper so that they were able to be, whether it was building leads or co-facilitators for future sessions. And that really became a very powerful model, so that even when, myself or my team is not present in a school, there are already people in that school who are championing this work. So we know that even though we're not there, their PLCs are still doing student work analysis in those PLCs, and they're still making sure to prioritize student thinking. I think as a field, we've been saying a whole lot about how we want to center students, but we're not necessarily walking the walk. Because if we are only doing it in instruction, but we're not doing it in assessment, I think that disconnect is really problematic. And we know, and I think Phil Darrow has said before, what gets assessed gets attended to. So if we're still so focused on all of our computer-based assessments on correct and incorrect answers, but instructionally we're doing things differently, then we're really sending the wrong messages to teachers and educators. So I think that if we're really going to be doing the work of centering children in the mathematics classroom, we have to think more carefully about the assessments we use. And that's not to say that computer-based assessments don't have a place. I think that data, and if you've read Street Data, which is a fantastic book, which would totally be in alignment with the assessments that I'm suggesting, there's satellite data, right? Educational leaders need that satellite data. They need to be able to kind of get a feel for what's happening across classrooms and schools and in a district. You want to know what district-wide what's going on. But at the end of the day, those computer-based assessments are not particularly useful for teachers. And instead of really pushing and spending so much time staring at the results of those computer-based assessments, it would make a lot more sense to arm teachers with the ability to understand student thinking, make sense of student thinking, and therefore be able to use it to make decisions. Are there any other questions that are being spurred for you? I'm also sharing, hopefully in the chat, you will get from, I'm sharing it kind of behind the scenes, the links, because the person supporting me on the back end here said I could send it to them and they would be able to put it in the chat. So hopefully that works. And then you can get that. But again, and I'm going to send that person also my email address. So that could be put in the chat, and my Twitter in case. So I don't know, there might be a delay here as well. So you might not be able, oh, well, I see it kind of streaming underneath my face. I don't know if you're seeing that too. But if you just Google search OGAP framework, you'll be able to see that as well. I'm going to give it another minute and wait for any questions. And while those questions may come in, I just want to share that, oh, you can only see it on the screen. Sorry, not in the chat. But there's my Twitter account. There you go. This is clever that they figured that out at least. I think it was Deborah Ball who said that our students won't believe their work is important until we treat them like mathematicians and value the work they do in making sense of the math in our classrooms. And I really believe that if we are going to do this work well, if we really believe that student thinking is important, we need to treat them that way. And I just keep thinking about not only the benefit to instruction, but the benefit to the beliefs we hold about children. When you sit and listen to teachers talk about their student thinking in this way versus looking at a percentage or looking at who's in red and who's in green, what you'll notice and what is most profound is that teachers just talk about students differently. And belief, in my mind, equals achievement. And I know that there's research that talks about that as well. When teachers truly believe in the capability of their students, when they believe that they're not these like blank slates or empty vessels to be filled, but that they have knowledge and understanding, then teachers are better positioned to create more equitable math classrooms and really empower students to move along progressions and ultimately accelerate their math learning. Okay, so we do have a question about how do OGAP progressions compare to math recovery progressions? Do you know? That's a really good question. And to quite honestly, I haven't really looked at math recovery progressions. I have looked at the math milestones, and I know there was a session on math milestones, Heather. So now you've given me something to do some more research and digging. But I will say that OGAP progressions are similar to learning trajectories, by the way. Learning trajectories is just the early, like birth to really early grades. But basically the OGAP progressions are, they took all the research and they just put it on a user-friendly one-pager that teachers could use to see the progression of the most important math of K, let's say K8. So, or even pre-K8. So additive is focused around like pre-K2, maybe you could stretch it to third grade. Multiplicative and fractional are 3-5, and proportional is 6-8. And I'm not 100% sure about math recovery progressions, but I would imagine that they would be somewhat similar. But again, don't want to speak to something I don't know about. And what was the name of the book I mentioned about learning progressions? That is a really good question. If I can find it. I can let you know. Just give me a minute, and if there are any other questions, I can get that name for you, Melissa. Give me a second. Okay, it's called Learning Trajectories for Teachers, Designing Effective Professional Development for Math Instruction. I wish I could drop it in the chat. I'm so used to Zoom and doing, webinars and sessions on Zoom. I'm now just learning. But that book it's the chapter 2 is the one that I referenced. But again, Learning Trajectories for Teachers. If you just look that up, you'll be able to find the book. It's a quick Google search. Okay, if there are no other questions, I think we're going to wrap this up. But again, I just want to thank you so much for sticking around and learning with me about learning progressions and how we can use that to accelerate early learning and really, again, to really center students in our conversations by using their work and using their thinking and not just relying on computer-based assessments to make decisions. I hope that is one of your biggest takeaways, and please reach out for anything. I love to talk shop. I love to think with other educators who are passionate about math instruction and thought partner. And I do hope that you will be able to take what you learned and share it with others. So again, thank you so much. Have a wonderful rest of your day and week, and I look forward to connecting with you further in the future.